everyone, and welcome back to the Platformers. I'm super excited. My name is Shani, and today I'm going to, we have a really special guest, Ran Isenberg, which I personally really love. Hey, Ran, how are you?
I'm fine. I'm great. How are you, Shani?
I'm good. I'm good. So, Ran, do you want to present yourself, or should I do it? So it will be proper introduction.
You go ahead. Go for it
Okay.
if you want. Sure.
So, Ran Isenberg, the author of Ran the Builder, which for all of the serverless enthusiastic, this is the go-to blog. I really love it. Ran is an AWS serverless hero, and I saw him presenting multiple times. He is a great presenter. Ran, did I miss something?
You're making me blush. The website, the blog post, the website is runthebuilder.cloud, where I write about serverless, AWS, platform engineering, things like that in general.
Yeah, so today Ran is going to share the platform engineering in CyberArk. And if you have any questions, just please post it here. We love questions. Feel free. I will read it out loud to Ran. And that's it. Ran, you can start.
Amazing. Okay, let me share my presentation. And like we said, you can ask questions along the way, and Shani will know when to stop me and let me answer. Okay, so Shani, do you see my screen? Everything is working?
Yes.
Okay, amazing. So hi, everybody. Today we're going to talk about how you can accelerate the development of SaaS services in your organization. And I'm going to share with you the automation that we've built at CyberArk that allowed us to reduce the time to production for every new SaaS service by 18 weeks. And yes, you've heard it right, 18 weeks. But before I'm going to start and explain why we built it and how we built it and what was our use case, I want to quickly introduce you to what we do at CyberArk to give you some context. So CyberArk was founded in 1999, that's 26 years ago. And we have over 4,000 employees across the globe and over 1,000 developers. And according to Gartner, we are leaders in two main domains, access management and identity security. We're a cybersecurity company. And over the last couple of years, we've become a serverless first SaaS providers. And that's where I want to shift the focus to and basically give you some background. So I think about 5 years ago, I joined the platform engineering team at CyberArk, and we wanted to start and build our SaaS frameworks to become a SaaS provider. And we started with the first SaaS service, the tenant management service or the customer onboarding service. And it was quite challenging because first of all, we didn't have any SaaS experience. We're mostly on-premise solutions at the company. We didn't have any experience with AWS. We didn't really understand fully what it means to be platform engineering. And of course, we didn't really fully understand what serverless is, but we knew that this is the future. This is what we want to build. So we started to build and learn along the way. And after some time, we've reached a maturity level in our tenant management service. So now we had a new kind of problem because we realized, okay, so we have one service down, but we have hundreds more to build. We need to build the entire SaaS control plane and then business services. So we started to recruit more people into the platform engineering side of things. And then the other teams at CyberArk who are running the business side of the business services outside of the platform, they also wanted to adopt serverless and join the new SaaS revolution. So now the organization had a problem. How do we adopt serverless across the organization? How do we keep standards and best practices from what we've learned at the platform team? How do we use the same tools for observability so we can track down customer issues across the SaaS? And most importantly, how do we replicate it and how do we do it quickly? So for that purpose, what we did is basically build an automation. And this automation has been used by hundreds of developers. It has created dozens of microservices. And in a nutshell, it's basically reduced 18 weeks of work per new SaaS service into a 3 hours automation. I think in general, we reduced years of development times, and if in the end, time is money. So we estimated that from last year till the end of this year, we're going to save over $1.5 million. And as we continue to build automation and add more content and make it better, it's going to save us even more. And yes, I'm not making this up. We actually presented this to AWS, and they were kind enough to write a case study about it. So it is working. I'm not bluffing. It's real, and we're going to see it and see what's the developer experience and how it works.
And this is a really cool case study. You should see it.
Yeah, so there's the QR code here, but if you miss it, all the links are going to be in the final QR code with all the links that I've included in this session. So what are we going to talk about today? First of all, I'm going to talk about what it takes to build a SaaS service in production. For me, it's a serverless side of things, but it makes sense for other types of services too. So we're going to talk about how you can take a hello world SaaS service and turn it into a production-ready hello world SaaS service. We're going to see the developer experience of the automation that we've built. We're going to talk about the concept of blueprints. Then I'm going to show you how the automation works under the hood. And we're going to end by giving you some homework in the form of action items. So a quick introduction about myself. I'm a principal software architect at CyberArk at the platform engineering division. Like I said, I'm an AWS serverless hero. And the website, I have a website called roundthebuilder.cloud where I talk about serverless and AWS and platform engineering in general. Okay, so let's start. So I want to talk about building a hello world production-ready SaaS service. But what is a service? So when I think about services, it's like opening a Pandora's box. You don't really know what's inside. Sometimes people did a lift and shift for a monolith. Sometimes they built something on Kubernetes. But in most cases, it's going to be a composition of microservices, where each microservice has a single responsibility of its own domain. It's scalable on its own. It's decoupled. It has its own API for input or outputs, and the team can work on it by themselves. So when I ask, what does it take to build a production-grade hello world service, what I'm actually asking is, what does it take to build all these microservices to make them production-ready? And I think in most cases, everybody starts with the backend microservice, right? So for us at CyberArk, I think the most common backend service microservice would be a CRUD API, where you have an Amazon API gateway that triggers an AWS Lambda function that writes to a DynamoDB table. This is the most common use case that we have. And I've created a hello world template, a production-ready template. It's called the AWS Lambda Handler Cookbook, and you can check it in the QR code here. But what are you getting in this template? You're getting a production-ready backend microservice. And for that purpose, you need to think about 5 elements: infrastructure as code, CI/CD pipeline, Lambda best practices, testing, and unified observability. So the infrastructure as code is gonna be a folder in our backend microservice, CDK code, Terraform, or Serverless framework, or whatever you want to use. It creates all the resources. And as you know, Serverless empowers developers to be more DevOps, right? The DevOps culture. So this part is maintained by the developers. If they want to add a new Lambda function, they're going to write the code that adds this Lambda function. And we're also going to have elements of security and governance, right? We're going to have, for example, in CDK, we're going to have CDK NAG, where it's an open source that scans the CloudFormation template output of CDK for any misconfigurations and security issues. We're also going to have a web application firewall set on our associated with our API gateway because we need security, right? And this is a production-ready service. So we also need the web application firewall with the organizational rules that we have. For CI/CD pipeline, we need all the tools, the linters, the security scanners. At CyberArk, we use usually Python. So the Python tools, linters, security scanners. You need the code that does the deployment to AWS with CDK, all the tests, and basically it needs to get you from PR to production, right? So again, it's a lot of work for even this very simple CRUD API microservice. Then we need to think about how we write our Lambda function, right? So we're going to use hexagonal architecture where we have 3 layers of architecture layers. So we have the handler layer, you have the logic layer, and you have the data access layer that interacts with the database. You need to think about security. So you need to think about input validation, authentication or authorizations. Maybe you have custom logic around that. And also you're writing to a DynamoDB table that might be used to store information from multiple tenants. So you need to have some tenant isolation aspects. So at CyberArk, we're using a specially built tenant isolation SDK. So even though it's a very simple CRUD API, we need to do so many things around it, right? Input validation, authorization, tenant isolation, so many things. It's becoming more and more a lot of work to do. And then we have the testing. So we have the unit tests, we have the integration tests, we have the end-to-end that we need to do. And again, it doesn't stop there. We need also the unified observability because we are a production-ready service. So we need to think about logs and traces and custom metrics and alarms to monitor any issues that we have in our CRUD API, even though it's a very simple CRUD API backend microservice. And we also need dashboards that gather all this information together and visualize this information. So what I'm trying to say is that even though it's a very simple, right? Seems like a very simple CRUD API backend microservice, we still have a lot of work to make it production ready. And usually services don't end with just the backend, right? You have the front end. So let's say that for our use case, we're gonna have a single web page application that is gonna basically talk to our backend and display items from the table. So you can add items, fetch items, delete items, create items, things like that. Okay, so we're gonna add the CloudFront distribution, we're gonna have a bucket that it's gonna hold React files, and we're gonna connect everything together. But here again, in order to make it production ready, we need to think about 5 elements: infrastructure as code, CI/CD pipeline, front-end best practices, testing, and telemetry. So this part is very similar to the other part. Here we need to build the CloudFront distribution, S3 bucket. Again, developers, they write it, they develop it, they maintain it, and you need to copy the React files to the bucket. And we're going to have CDK again, and we're going to have the WAF, but in this instance, it's going to be on the CloudFront distribution. Now, the CI/CD pipeline is going to be very similar. It needs to get you from PR to production, but here it's probably not going to be Python. It's probably going to be maybe TypeScript. So it's a different language, different tools. As for the front end best practices, here we should develop our components in a modular way, so we can test them in an isolated manner and reuse them. We need to implement the integration of the backend API. We need to think about security, how we can log into the web page, the refresh token, the logout flow, all the cookies. We need to think about caching, performance, accessibility, error handling. Again, a lot of work to make it production ready for a very simple front-end microservice. As for testing, we need to think about unit tests, tests that we run in the local host. End-to-end, maybe we're using Playwright or Cypress. We need to think about different client configurations, mobile clients, resolutions. Again, a lot of work for a very simple web application. And lastly, we're going to add telemetry. At CyberArk, we're using Mixpanel. It allows us to really understand how the users are working with our UI, so we know which parts, which features we should spend more time and develop, and which features are not really necessary. So again, these are the 5 elements to make it production-ready front-end microservice. But it doesn't end here, because every service in the end needs to integrate, every SaaS service needs to integrate with the SaaS control plane. So you might need to connect to subscribe to an SNS in a different AWS account, right, in the SaaS control plane. You might need to have some role delegation to do some assume role and execute an API get with an IAM authorization. So it gets more complicated. And at CyberArk, for our use case, we need to integrate with the tenant management service, which means sometimes to have the subdomain registration for every new service. You have a subdomain myservice.cyberark.cloud with a certificate that basically customers can talk with the API of the service. And like I said, you might need cross-account access, protected APIs, SNS, pub sub, things like that. So what I'm trying to say is that production is complicated. One microservice is not enough. We need multiple microservices. We need to have integrations with other services. And in many cases, we need to deploy to AWS accounts, multiple AWS accounts, dev, test, stage, integration, production, because AWS recommends that we split those into different accounts. And in many cases, you also need to deploy to different regions. So it gets even more complicated. So everything that we've seen just now, we estimated that for a veteran team of 4 people, to make this hello world service with all the elements that I've just shown you would take 18 weeks. Okay, so this is the number that I'm talking about, 18 weeks. And this is why we build automation that turns these 18 weeks into less than 3 hours. And in the end, you get all the items that I've just seen you. So this is what makes our hello world service in a nutshell. Okay, so let's see the automation in action. How does it look to use it? So it all starts at the developer portal. We're using Port, which is a developer portal. It's a SaaS application. You go to the self-service hub, you click on business service create, and you have this form. Here you're going to select the GitHub organization, the service ID, which is the enum of the service in all the internal SaaS control plane. This is how it's represented in the API calls. You have the service name, which is the display name that customers are going to see in the SaaS application picker of CyberArk when they are going to buy this service and have it displayed in the SaaS UI. This is the subdomain that the customers can send API requests to. And lastly, you're going to select which team you are and click on execute. So when you click on execute, the magic will happen. So what will happen is basically you'll have, we're going to start and clone and scaffold 6 templates in this case. We're going to go one by one to create the GitHub repositories for each one of them and start to deploy them to AWS across multiple accounts and regions. So at some point, after less than three hours, like I mentioned, everything is going to work. The service is created, all the microservices are deployed, and then all that's left to do is to actually create a tenant that buys this new service, the one click, because for every tenant that CyberArk has, you basically choose your subscription. You select what services you want to pay for. So let's say that for a customer paid for this new service, and they're going to have, when they log into their tenant online, they're going to see in the application picker the one click. So once we do that, you can see that when we log in, you can see on the left, you have the one click, the display name that we chose with the default icon. And you have in the middle, the one page table with items that for the purposes of this demo, we've entered. So these are items that are fetched from the DynamoDB table from the backend. So we have also front end and the backend and the SaaS. Everything is working together. And we also have some feature flags. You can see the FF enabled. We have some feature flags. We're using app config if somebody cares. It's a great service, AWS service, and basically you can see all the things, all the microservices in action together. So what did we see? What we've seen is actually a self-service serverless automation that allowed us to create a serverless SaaS business service, which we called one-click, and we used something that we call blueprints. And I'm going to explain what is a blueprint in a second. In the end, we created 6 GitHub repositories with their pipeline. We're using Jenkins, and we deployed them to 4 different AWS accounts: dev, test, stage, and integration. And integration, we deployed to 2 different regions. And it took us 3 hours because there is a dependency there. We can't really deploy them in parallel. There's a dependency of resources between them. And because we deploy some of the resources like the CloudFront distribution, it takes like 15 minutes per account. So it takes more time. So it's bound by 3 hours, but it's usually less than that. Now, if I'm wearing the developer's hat, for them, they're getting a production ready Hello World service. So now for them, all they need to do is start to develop and focus on the business domain, which is what we really wanted to have in the first place. Now I want to talk about the concept of blueprints. So blueprints are basically a microservice starting point. They're basically a GitHub repository, a template GitHub repository that has all the best practices, and you deploy them. And for the developers, they don't need to reinvent the wheel. It reduces their cognitive load, as we like to say, in the platform engineering domain. And they can really focus on writing the business domain logic. Now, as for the organization, it's great for governance because now we know that everybody's using the same tools, all the best practices, and we're using the same observability tools that are built into this GitHub repository. So in the first example, I gave you 3 microservices, but in the end, we split it into 6. Doesn't really matter why, but we have 6 blueprints in the end. Okay, so Shani, do we have any questions, or should I go and show and spoil how it all works?
Yes, so we do have a question from Daryl, which is a solution architect at Sienna in Believe in Serverless community, and is from Canada, snowy Canada, and is asking, what is this tool you're showing now? A CyberArk, it's a CyberArk one or something yours?
No, it's the one, it's what we built at CyberArk. That's actually the automation that we've built at CyberArk. That's the developer experience, and I'm going to show how we built it and how it works. So yeah, real, not a POC. It's actually working. Yeah.
Yep.
Other questions?
No. You can go on.
Okay, so let's talk about how it works. So we have four elements in the end. We have the developer portal, which triggers the blueprint orchestrator that uses blueprints. And one of those special blueprints is the SaaS control plane integration blueprint. So like I've mentioned before, the developer portal is port. It's a SaaS service. It provides us with the form of parameters, and it's going to trigger our blueprint orchestrator via Kafka messages, and it's going to show us the status and logs along the way of what's the progress of all the initiative. For the blueprint orchestrator, so again, this is serverless. We're going to use it's basically a step function state machine with Lambda steps, and what it does is basically call Jenkins, GitHub, or Snyk APIs to make sure that we can use the blueprint and create the microservice from scratch. And then it runs its Jenkins pipeline, which this is how we use to deploy. It's wait for its completion, and then it goes to the next one. Like I said, we have 6 of those, so it knows the order that it needs to deploy them, to create them, and it passes the configuration of the form to each one of them. Now, as for the blueprints, they basically create the microservices repository They run the CI/CD, they deploy to AWS, like we've seen, 4 different accounts and different regions. However, one of these blueprint is a bit special. It's the SaaS control plane integration blueprint. And this blueprint, which I'm going to write about in my next blog post, it uses AWS Service Catalog, which is a very nice AWS service. Again, it's serverless, and I think it's the best friend for any platform engineering team. It allows us to create a portfolio of CloudFormation or Terraform templates, have them versioned, and then people from cross organization can use the portfolio to deploy these templates in their AWS accounts. And once the one-click service is going to build and deploy this blueprint, it's going to deploy the CloudFormation template. And this CloudFormation template is going to trigger a serverless automation that will create the SaaS control plane cross-account access in a dynamic manner. Now, it might not make any sense when I say it now, but for that purpose, I have this slide, which is the most complicated slide that I have. And don't worry, it's not that complicated. We're going to go over it very slowly. Now, there are 2 links above. One on the right is the AWS Developers Podcast, where I talk about in depth about why we built this part and how it really works, because this is a simplified version of what we actually built. And this is the innovation of the entire automation, to be honest. On the left, you have, I actually open sourced the entire solution, so everybody can use it. And it's based on CDK and Python. So what you see here, the entire version, you can use it in your own organization. Okay, so what is the purpose of what we're doing here? On the left, you have the one-click AWS account. And our goal here is to have a role on the left that can assume the role on the right, which is the SaaS control plane, and do some, through that role, access a protected IAM authorization Lambda path, right, on an API gateway. Or it can even be an SQS on the left that wants to subscribe to an SNS on the right. It's the same principle. So what we're going to do is basically we're going to deploy our blueprint, which uses a service catalog to deploy. It's called a provision product. So in the end, it's just a stack, CloudFormation stack that it fetches from service catalog, the template itself, and it's going to create us the IAM role that we're going to want to use. Then it creates an AWS CloudFormation custom resource. Now, this custom resource has on one side the IAM role ARN that we've just created. On the right, it's going to send an SNS message to the SaaS control plane SNS topic. Eventually, a Lambda function is going to get invoked. And now this Lambda function has, on one hand, it has an environment variable of the IAM role in its own account. And it got as input the IAM role ARN from the left. So now all it needs to do is call an AWS SDK API and edit the trust relationship of this role and make sure that the role on the left can assume the role on the right. And that's it. This is the cross-account access magic in a dynamic manner. Once it does that, it can release the custom resource from its wait state, and the deployment is completed. Now, like I've said, I have the open source for it and the podcast where I explain this in more depth. So in the end,
we have
yes?
another question from
Great.
Erez Mizrahi. So Erez is asking how the development team are actually using this automation. It's basically creating templates as a Git repo. Any team can clone.
You don't need to clone it because you're getting your service with everything scaffolded out of the box. You enter your service name like I've shown you in the form. You enter all the parameters that you need for the integration with the SaaS services. You click on execute, and 3 hours later, you have 6 GitHub repositories with your service name ready for work. It's already deployed, connected to the SaaS control plane. You're ready. You're good to go. Just enter your own business logic and deploy. I hope that answers the question.
If not, Eris, just feel free to ask one more time.
Okay,
Okay.
so
Yeah.
so so you have develop portal, blueprint orchestrator, and the blueprints and the special SaaS control plane integration blueprint in the end. So now this is the fun part where we're gonna give the audience some action items and homework to think about. And the first thing that you should do, if you haven't noticed already, is basically build blueprints. Now we didn't start with the automation that I've just shown you on the first day. It took us years to get to this point. So what we did is basically we started with a blueprint with the GitHub template for one microservice. Then we added the solve service for that blueprint. Then we started to add more blueprints. At some point, we decided to add the developer portal to make it more user-friendly than just doing things in Jenkins, which was not the best user experience. And then we thought, hey, if we have this UI, maybe we can automate multiple blueprints because our blueprints have connections between them. And there is it's complicated to understand how to get to the SaaS control plane integration, how to make everything work together. So then we figured out how to automate everything together and make it work. I think that was like the final part on the evolution. It takes some time to get to this part. And lastly, my tip for you is to use serverless services because one, they're great, and they're very simple to use, and you don't pay for when you don't run the actual automation. That's also a very big bonus. So like I've promised, here's the huge QR code that you can use to get all the links that I've shown here, all the podcast, the open source part of the cross-account access automation, and you have my website here. Yeah, I think we're ready for more questions, guys.
Thank you, Ran. It was super interesting, as usual.
Thank you.
Okay, so I'm not sure that we have more questions, but if you do have more questions, I think that Ran, they can feel free to just reach out over LinkedIn or whatever, right?
Yeah, LinkedIn, X, Blue Sky. My website has a mail there. Sure. Yeah.
Okay, so let's wait maybe 3 more minutes. And if we don't have any question, so we can just go on, move on. So, Ran, how much time it took to build the platform in CyberArk?
I'd say that we didn't really finish to build it because we're continuing to build
First
and add more people, and the challenges they started with have something that works. Then you have build more services, more frameworks, more SDKs, and then at some point you start to tackle more challenging features like chaos engineering and cross-region disaster recovery and more advanced topics. So it never ends. I think that's the beauty of the job. It's super dynamic, super interesting. It's basically SaaS 101, and when you start from the beginning, you just learn how to make SaaS, which is super interesting, like from everything, like login, authentication, authorization, everything basically, until you get to the more advanced, interesting part. Also, like I mentioned, chaos engineering and things like that.
Nice. So we have another question from Daryl. So he mentioned that his question earlier was about the tool you were using to set up a new app or tenant. Someone else mentioned it's Port.io.
Yeah, first of all, hi, Daryl. Yeah, I know Daryl. He's awesome. Yes, it's Port. It's Port. Yeah, it's Port. It's an Israeli company that does. It's like an alternative for Backstage, where you get it as a it's a completely different product, right? It's not Backstage, but it's a SaaS service. It makes it much easier to use than Backstage, where you need to write code. You just need to configure things and connect it to your own system. So this is one of the reasons we chose Port, because it's super configurable and easy to use instead of deploying Backstage and managing the entire thing.
Nice. So we have another question from Anton. Hi, Anton. How are you? We know Anton and we love Anton. So Anton is asking, how did you convince your development team to use your platform? Was it some sort of executive mandate, or did they realize their value on their own?
Wow, that's a that's a question for like 10 minutes, to be honest. I think in the beginning, yeah, we really needed to prove that we know what we're doing, which we didn't, to be honest. We made a lot of the first integrations were very hard. Like, we made mistakes. We didn't understand fully their side. We didn't understand how to be a platform. But once we did, we got feedback. We grew. We made things better. Documentation, developer experience. We got feedback from people, so we started to make the things better, and then people saw the value. But in the end, I think it also needs from people from above to say, hey guys, give these guys the chance. We look at the bigger picture. You should use the platform, because I can make the most amazing SDKs, internal services, external services, whatever. I can't force anybody to use it. I can make the experience as best as I can, but in the end, they need to see the value. They need to know that if something is not working as well, they can give feedback, and I will actually listen and make changes. And it also this mentality needs to also come from the executive, which was our case. Basically, we wanted to do a platformization basically at CyberArk. But again, it goes both ways, because if I'm not doing a good job, it's gonna fail, and people are gonna develop their own variations of what we do, and then the platform is gonna not work, and they will have a good reason. Like, if it's not work, it's not useful, it's not saving them time, they shouldn't use it. So you need to listen to the internal customers in the end.
Yes, and you can build the best product, but if the customers doesn't want to use it, so it can be a great product on the shelf. And yeah, I think this is one of the most challenging parts in platform engineering, actually.
Yeah, true. And you need to prove yourself all the time. So every new thing that you do, you need to get feedback. You need to understand that your design is working correctly. And once you finish the development, guys, did we make a good job? Is this solving your problem? Do you want something else fixed? So it's a never-ending loop of providing value to the teams here at CyberArk.
Yeah, it's actually having a product mindset all over.
Yeah, we actually have a product owners, product teams
Nice.
that get requests and requirements from other teams. So yeah, we treat it like a proper product. Yeah, it's true.
Nice. So we don't have any more questions. So Ran, it was a pleasure to host you here, and
Thanks for having me.
really love listening to your sessions. So thank you very much.
It was awesome. Thanks for having me, and let me share the story of what we did at CyberArk. So thank you.
Perfect. Bye-bye.
Bye. Have a great day.